Specific questions, and so I couldn't answer because I was like, is this talking about paragraph? Like, I don't know which one.
Thank you.
But I'm scared of, because I wanted to select maybe 11 questions and the spirit was like, because I wanted to stay to do it, and it's so like they just don't finish it because it's labeled wrong. So I took 30 minutes before I actually like the time was like up, so just in case like I would have time to do it. What do you think she'll do lunch? Since we're here. Then she's stressed out that she's not going to. I don't know. But I'm just scared that she's not going to let me.
One, two, three. Actually, this is business.
Like I literally started crying. It's like the first grade that she's like missing like her hand. And I have to write an essay too, so if I mess up multiple choice, which is enough. How come you're only president? You good? What did you get?
Alright, we got a couple things here right at the start of class. First is I want to give a couple points for participating on the FRQ packet. So the packet of 4 FRQs. If you did not turn that in Google Classroom and you did not turn it in up here, then I need you to do that for me, please. You need to do that first. Then we got a 2-question mini quiz that I've been delaying because we have been at home. But this is no calculator. The 2 questions come straight from the notes like I told you they would. Cleared off. So, if you are comfortable with U substitution, you can just work on that as normal. And if you don't feel that comfortable with it, again, the questions come straight from the notes. So, if you look those over, then you've got a leg up on it. Now, this one's only 2 points, so it's either right or wrong. No, 2 points isn't much. we'll count them as major points though to really reward you. So take an extra minute if you need to. Don't feel like you have to rush here. But I will be given a similar type of mini quiz on Thursday. Same use substitution topic. I will even tell you where the questions are going to be pulled from, and that's up on the agenda that you can look at when you're done. But it'll be worth 4 points that time instead of 2 points. So today's is a little less risk, but you should still aim to get them. Finish, you can quietly turn it into the basket, or you can hold it up and I can get it from you if that's easier. And then you're welcome to get your notes out and see how you did. Of course, I'll give it back to you too, but just in case I don't have time to get to them today, we could look up and see if you got the same answer.
How are you?
Good, how are you?
Doing fine. I'm on an errand for her. Do you have enough to do 622, enough calculators? I told her we'd probably do, but we'd have to take them up from teachers.
Oh, yeah, we'd have to take all the teachers.
Yeah, and then I said in the past that we had proctors put a sticky note outside the door and just delivered them, but I said we still had to take them up from teachers. And she said, yeah, that's what she's done, but she said she just wanted to make sure that we had that many calculators. And I said, I need to double check with you.
I don't know, 600?
22, yeah. But think about it, you probably have ACT kids just
That's true.
okay.
The minus a few, yeah.
Yeah, minus a
That
few.
Teachers may have lost, but that's what it's coming back after the start of this year.
Okay, so that's with the big clunky ones, right?
Those are the
The
big
thick,
battery
yeah,
ones.
okay. As long as we have enough batteries, we should be good. Okay, I just told her I'd have to come check with you, and then I'd let her know, and then we'll work out whatever plan she wants, I guess, after that.
Okay.
Okay, all right,
Yep.
thank you, sir, appreciate it. Sorry to interrupt.
You're good.
give everybody another minute in case they're still working. But for those of you that are finished, the main thing we're going to look at today is the Chapter 5 review, which I did ask you to look at and spend a few minutes on as part of our Thursday assignment. So you can go ahead and get that out, and unless you've just done the whole thing ahead of time, which I doubt many people have done that, you could start working on your own for a minute until I can join you.
I didn't turn this in at the beginning because I walked in really late.
If you're still working, I need you to finish that up and get that turned in. Again, since we have lunch and a break here, I can probably get these back to you guys today. But, of course, use substitution is the big part of what is different between our last quiz, which, as I told you, I thought is probably the hardest one we have all year. Certainly the rest of the semester, and your next Chapter 5 test. So we were on pace to test this time next week, but with the AMI and stuff, it has slowed us down just a touch, which, I don't know, I would think you might be happy about that, but of course, in the end, that's going to be just one less AP exam review day that we will have. But I have to get you guys to be moving forward on this use substitution stuff. So first off, if you felt like you were caught off guard, you've got to do a better job of keeping up with reminders. Every time I saw you guys on AMI, I told you I put it on Google Classroom each time. I don't know. I tried to make it as easy as possible by telling you exactly which questions to look over. But same thing on Thursday. So if you feel like you missed this opportunity, again, it's 2 points. Not a big deal, but it does add up. The one on Thursday will be 4 points. The 2 questions I pick from will be from 82 only the first part of that book assignment. So there was like 9 questions there. So you should look back at those between now and Thursday and make sure that you could do any of those 9. And if you don't think that you can, you probably need to repractice those. So you might want to write that down, or I guess you could always pull up the agenda again, but you guys need to think of that stuff. Especially as we get closer to the AP exam. I'm going to do lots of small quizzes like this because I'm just trying to break the material up into small manageable pieces for you, but you got to stay on top of that. All right, quickly I need to tell you that we do have the ACTM math competition coming up if you are interested in that. The last couple years have been not much participation, partly because of COVID and stuff. The flip side was that we were able to offer it here at the high school. Made it very easy on students. Typically, the normal way they do it and the way they're doing it this year is it's only on a Saturday. I think it's March 3rd or March 4th or something. Usually, calculus AB students don't sign up for the ACTM because you are also competing against BC students. But if you are interested in doing that, there is a $5 fee. That's not something that the high school's making money on you. It's what the university charges. So I would need that by next week at the latest. So if you think you're interested in that, let me know, give me the $5, and I will sign you up and let you know where and when exactly that will be. But it's like March 3rd or March 4th, whatever that Saturday is. Okay, any questions about that? Okay, then on your review, so I went ahead and printed you out a hard copy as well. Some of you may have already done that, and that's fine. You can just have an extra copy. It's not going to hurt you. But let's, I'd like us to maybe start off by looking at a few of these together. And then, again, I know you have not finished it. I haven't given you enough time to finish it, but I need you to start working through that and finishing it up before Thursday so that whatever it is you're struggling with, I can help you with. So the front page is 3 different FRQs. The back is some practicing integration, specifically some U substitution, forcing you to think about area under a curve, which is still just integration. A few other things that we did in 5.154, like average value, trapezoidal sums, left Riemann sums, the first and second fundamental theorem of calculus is in there. So one thing we will do on Thursday is I will let you see your last quiz, because some of those same question types can and will show up on your Chapter 5 test, so it's good for you all to see what you missed, and we'll go over a few of those, especially the more missed ones, to give you some ideas of what you should have tried. And then we need to use this as the for making sure that you're ready for the rest of it. So since you guys have looked at this a little bit, these FRQs on the front, FRQ 1, 2, or 3, which one of these looks like it would be the hardest to do? The second one? Okay. Then let's all go ahead and do FRQ 2 together. Now, if this is one that you just already did, that's great. If you want to pay attention to the parts that you found to be difficult on part 2, then that would be helpful. But if you're good with all of it, then you can just work on another question, maybe on the back or one of the other FRQs if you haven't looked at all 3 of them yet. Okay, so FRQ2 says a particle moves along the x-axis. So x-axis is horizontal, and there's some particle that's moving back and forth. And between 0 and 16, his velocity is e to the 2 sine t minus 1. Also pay attention to the top directions there. It says calculator would be allowed for FRQs 1 and 2, so we can use a calculator on this one. And it says the particle is at the origin, at the start. So at time 0, we know it's at 0, 0. Okay, during what intervals of time is the particle moving to the left? Give a reason for your answer. So how are we supposed to know when this thing is moving left or right?
It's negative.
When what's negative? Okay, so we could say something like, when velocity is negative, it will move to the left. So that's kind of our reasoning for our answer, but we still need to say when that happens. So what would be an efficient way to know when the velocity is negative?
Less than 0.
Okay, so
Just use the calculator.
okay, so let's go ahead and graph it. You could graph now, because I'm throwing a trig function in here, you do have to be in radian mode. If you're in degree mode, your calculator will try to fix it and make it look the way it thinks you want it to look like, but radians is what we want. Now, this graph is not super helpful because this is -10 to 10 and -10 to 10. This is the standard window size. What x values should I be interested in here?
0 and 16.
Okay, so let's just change x min to 0 and x max to 16. So we're only looking at the parts that we are interested in. So can you see where velocity is negative? So it's just a matter of figuring out these values so we can give this range as an answer, figuring out these values so we can give this range as an answer, and is that it?
This one over by like 15.
Yeah, you got to be careful here. Now, on the AP exam, they expect you to get within 3 decimal places correct. So some of you guys will just do trace, and you'll get the cursor kind of close. And sometimes that's good enough for multiple choice because you can narrow it down to a single choice. But this is not going to be good enough for 3 decimal places. So if you do second trace, option number 2, it helps us find zeros. Left bound just means move the cursor to the left before you hit enter. Then it will say right bound, move the cursor to the right before you say enter. And then if you wanted to guess, you can put in a guess, but I just hit enter to skip that. And then the calculator will bounce back and forth until y is 0 or until y is basically 0. So it looks like the first one is at about 3.141. 3.141 until this one. So you've got to do it again. Second trace, option 2. Make sure your cursor's to the left of that. For left bound, move your cursor to the right of it for right bound. And then it will do the rest of the work. 6.283. These numbers kind of sound familiar too. You recognize what these are? This one was probably like pi and probably 2 pi. 6.283, I think. Okay, and then we just got to do that a couple more times. So this is kind of unusual that they would have you do the same thing multiple times, but because if you could do it once, then you should be able to do it the next time. But left bound, right bound, enter. 9.425 is the start of the next interval. And it goes to 12.566. And it looks like there was one more.
Now this, I do believe they would put on your AP exam because they're making sure that you're paying attention here. Actually, you know what? They may have put the second one here for people who don't change their window settings. Like if you're just looking negative 10 to 10, you're not seeing the full picture, so that would be an easy mistake to make. Okay. About 15.708. And then that goes on till 16, till the end. Okay, so you guys have used this trace feature before, find zeros. You know how to use your calculator to do that for you. I'm not going over that part too quickly. Okay. So we really only have to know this one little thing. Velocity is positive, it's going to the right. Velocity is negative, it's going to the left. Here is my answers. These are the times I think it is moving to the left, and here's my justification, because velocity is negative during those times. Okay, that look okay? Any questions about part A? So you can do that on the test? Making sure. All right, part B. Find the total distance traveled by the particle from 0 to 4. Well, that word total distance means something. What do we always have to do when it says total distance? Okay, absolute value. And how are we supposed to know the distance traveled if they gave us velocity? One more time. If you take the derivative of velocity, you get acceleration.
Oh, so you anti-derivative?
Right, so you want to integrate. And if you integrate velocity, it gives you the change in the function below it. So if you integrate acceleration, it gives you the change in velocity. If you integrate velocity, it gives you the change in position. So if you threw that in your calculator, you guys know where the absolute value signs are in your calculator? That's very important. If you don't, make sure you ask me sometime today. But I'm going to skip doing that as a group here just so we're spending less time on this. It should give you that. 10.542. That's all you needed. So again, we needed to know two things here. Absolute value signs because it wants total distance. So whether it's going to the right or to the left, we wanted to add it up. 0 to 4 because that's the times. And to get the distance traveled, the change in position, that is integrating velocity. Integrating velocity gives you the change in the function below it. Okay, and then finally part C, is there any time between 0 and 16 that the particle returns to the origin? Well, how do we know if we have velocity? We know that we start at the origin, and then he starts moving. Looks like he moves to the right for a while, and then to the left for a while, and then to the right for a while, and then to the left for a while, and then to the right for a while. How are we supposed to know for sure if it ever returns back to the origin? Yeah.
Graph the position.
Okay. That's a good idea. How am I going to graph the position function though? They didn't give me a position function.
You integrate the velocity.
Okay, and if I ask my calculator to graph that, so sure, I can type in velocity equation over here. E. Make sure you guys are using the correct E. This is not this capital E when you're like typing a letter. It's the lowercase e, the number. And I'm going to use x instead of t, but just instead of dt, I do dx. The problem is my calculator is not going to let me do this because I don't have any bounds. So integrating velocity gives me position, but I need to know, well, what is our start? What value of t should we be starting at?
0.
Okay, now you're going to be tempted, I think, to put in 16 here. The problem is if you put in 16, you're basically asking it at what position, like how does this change from 0 to 16? So it's going to say, well, it's going to compute this, it's going to get a number, and that's going to be your position at time 16, which I'm guessing is just a straight line, but it may not even show up on the graph. Okay, stop. So it's not 0 to 16. We don't know when it is going back to the origin, but you need to make this not 16, but a variable, 0 to x. So like, let's say it's back to the origin at 1. So that would be when x is 1. So this would, if it crosses the x-axis when x is 1, then that would tell us that it's back to the origin, because that would be its position. But this could be 1, or it could be 1.2, or it could be 7, or it could be 12. If you put in a number here, then it's not going to change over time. So that is pretty hard for your calculator to compute, so you can see that it struggles. It's doing hundreds, if not thousands, of integration questions at once. But here's, since we integrated velocity in our calculator, this is its position when x is 0, this is its position when x is 1, x is 2, x is 3. It's changing that x each time it's doing the computation. So if it returns to the origin, what's going to happen to our graph?
Can you go back to 0?
0,
And
this,
y.
okay, down here, right? When y is 0. Still thinking. Okay, you think we should wait longer, or are we ready to make a guess?
Just make a guess.
Okay. So when is it returning to the origin?
Yes.
Doesn't. Never does. Let's see if it's still processing. Yep, still processing. I guess it's up here a little bit. Okay. And then how do we know? We can't say because the graph doesn't come back to the x-axis. You can't use the graph in your justification when there's no graph.
The integral velocity only reaches 0.
Okay, integrating velocity from 0 to t, or x is what we used. What we wanted to see if this ever equaled 0, right? And it didn't. It was always above. It's always greater than 0. It's always above the x-axis. Still thinking there. Oh, that's us. Okay, make sure you copy that down before you head out, please. I did pass back your mini quizzes from today, so again, if you just forgot about it, forgot to look that over, do something different to remind yourself to look it over. It's just from the first part of the book assignment, So there's like 9 questions. I'm going to pick 2 of them, and it will be worth 4 points next time instead of just 2 points. So what's important is that you get it down, but when we get to your test, which is, I think I misspoke before lunch. It'll be this time next week. I forgot that Friday was, this is a B week. So we were planned on having the test on Friday, but now it'll be next Tuesday. Use substitution is the biggest question type. There's like 3 or 4 or 5 of the questions on that test are just use substitution. So it's one you can't afford to feel shaky on. Okay, let me get out of your way for a minute. So try FRQ1, skip the parts you're not sure about. If you finish it and you think you've done all of it correct, then look at the solutions online to make sure before you keep on going. And then I will butt in here in about 10-15 minutes to help out. Okay, it's been close to 10 minutes, so let's make sure that you know how to do each of those parts, and then I can go more in depth in the execution of each part if need be. So just a quick scan for FRQ1. They gave us velocity. And part A wants us to find position. So how do you get from velocity to position? One more time. Okay. Now again, I'm not like actually working it out. I can go back and work it out if you need to, but you need to understand why you're integrating there. B, we have velocity, and part B wants acceleration. So how do you get acceleration from velocity?
You take the derivative.
Okay. Part C, when does the particle change direction? How would we know when it changes direction?
When the velocity is zero.
Close. When velocity changes from positive to negative, or from negative to positive. Just because velocity is zero doesn't mean it's switching. It could be positive, zero, and then positive. So calculator will do that, and we can look at it if we need to. D, speeding up at time t equals 1, t equals 2. How are we supposed to know if it's speeding up or slowing down?
Acceleration.
Okay, you would need to know something about acceleration for each of those times. What else?
Velocity.
Okay, and then something has to be in common. Right, you should be looking for same signs or different signs. If they're the same signs, they're speeding up. If they're different signs, they're slowing down. Okay, and then E, total distance traveled. So if we have velocity, integrating velocity gives you the change in distance. And if you want it to be total distance, so even if you're going left, it's adding, you need the absolute value signs, and if it's over the first 5 seconds, 0 to 5. So that's the stuff that you just have to know to even start these questions. You have to know how to get from velocity to position, velocity to acceleration. You have to know that velocity is showing you the directions. So with our calculator, we can figure out when that happens. You need to know how to know if it's speeding up or slowing down, and you need to know how to deal with the total distance with the absolute value sign. So of these parts, A through E, which of these do you have trouble trying to find the actual answers to? John?
Well, I understand what's up here for me, but why on the answer sheet does it have like a really longer process?
Well, it just depends on if it's calculator or not. If you have a calculator, you can do absolute value sign and be done. But in theory, you can do it by hand without a calculator. So I don't know what this graph looks like, but technically from your work in part C, you know where it's touching the x-axis. So like, let's say it looks like this. If you know from here to here it's above the x-axis, you could integrate that part. So I don't know where this is, but let's say it's like 3 or something. And since it's positive already, you would have that. But then from 3 to 5, if this is negative area, you actually want to add it so that it increases. So then you could subtract that negative from 3 to 5. So it is possible to do by hand the absolute value signs, but the AP exam never expects you to do that by hand, so we don't expect you to do it by hand. So if you want to go that route, they'll give you the points for it, but like you're adding a lot of work to get what they're doing. But that's what they're doing. They're doing it by hand instead of just plugging it in the calculator and letting the calculator do the work. It should always say this or this, but that's how you would do it by hand. You'd have to figure out what's already positive, keep it positive, what's negative, make it positive, and then add all the parts together. So A through E, any of these, the executing of getting the answer? Yeah.
Could you work out C?
C? Sure. So if you need help with C, then please follow along. So with C, when does it change direction? I would graph velocity. And well, I guess we do have to think about this function a little bit. You could zoom out a little bit if you wanted to, but this thing is never coming back down. This is the direction it's always going to take. So when velocity is negative, he's going to the left. So if you're looking at a velocity graph, it's when it's below the x-axis. When velocity is positive, he's going to the right. And so right here, it's switching from negative to positive. So he was going left, and then he's going right. So right there, trace to 0 like we did earlier. Looks like it's switching at 1.792 seconds. Is that enough there?
Yeah, I think on your answer key would just set it equal to 0 and then solve it from there.
Oh, they didn't solve for it? Yeah, they should have. The one thing y'all do need to be careful about on this, and someone said this a few minutes ago, but this is very common. Your justification can't be because this is when velocity is 0. If your velocity is positive and then 0 and then positive, it never changed directions. It was going to the right, it stopped for an instant and then went further, then started going back to the right. You actually have to switch from positive to negative or negative to positive, not just when it's 0. That's not specific enough.
So if you have to do it like completely algebraically, would you have to like test points around it to justify that it was going from or changing?
I guess algebraically what you would need to do is set it equal to 0, which is like basically looking at where it is on the x-axis. You could solve this. You'd have to mix in some logarithms, like take the natural log of both sides, bring this down. The natural log of e is 1. So the exact time, the same thing my calculator did, but this would be exact, would be natural log of 6. But there's only one time where that happens. So then, yeah, I guess you could test, something a little bit smaller than that, but what's smaller than natural log of 6? Like without a calculator, without estimating that, that's kind of hard to know like how big that is. So I don't think they would ask you to do that without a calculator. But let's say that the work came out nicer and it was at like t equals 4. If this was the only time the velocity was 0, yeah, you could test like 3 into the velocity and see that it was negative, and then maybe 5 into the velocity to see that it's positive, and then you could see that it was changing directions. You don't need to be as specific as it was going left and then going right, but I guess you could do that. But for the function they gave you here, that's not very realistic. Okay, the execution of any of these other parts. Okay, make sure that you guys put a star by the ones that you got hung up on or you didn't know how to start them off, because all of these are very, very common question types. So, of course, our actual FRQ won't look exactly like that, but there's a good chance it might ask you to go from velocity to position, velocity to acceleration. This is the second one today. We've talked about particles changing direction. This is the second one we've talked about today, doing total distance. So a lot of these are very consistent. Okay, if you haven't, go ahead and do the same thing with FRQ3, please. Go ahead and read each part, try them out, see how it goes, and then that help you identify which ones you don't know how to start, and then I will come back and help you with that piece. And then we can talk about the how to execute each part if need be. So let's do this, the same thing here and talk about how to start some of these, because that is the most important part. If you don't know what it's asking or how to start some of these, it doesn't matter if you can finish them. I would say part A is, well, it's got 3 parts to it, so that's kind of unusual, but this actually does get asked a lot on the AP exam. So like the FRQ packets that you guys turned in today, the very first one has some work of finding this area under the curve, and that's some of what we've got to be doing here. So G of 4, well, G of 4, this function that they graph for you is G of X. So G of 4 is where you plug 4 into that. So how are you supposed to, if I plug 4 in for X here, they don't give you a function, so you can't integrate it or do antiderivative. You can't use your calculator because you can't plug in the function. So what's the other way to figure that out? What's a visual for integration? So that's what they're asking you to do in part A. How much area was under the curve from 1 to 4? Plug in 4 for X, and the only way for me to integrate this, since I don't know the function, is to compute the area. So it was really just the area of a triangle. Now again, I'm not going to work out the answers because it's good for you guys to go back and try that again, especially on the ones you didn't know how to start. But G prime of 4, here's what I like to do on these questions. I think it makes them quite a bit easier. You've got this written down for you. So if I want to know something about G prime, I'm taking the derivative of this side. What happens when I take the derivative of this side? F of X. So if you want to know G prime of 4, it's really the same thing as F of 4, right? Which is what? -1. Answer is right here in front of you, but you have to know the second fundamental theorem of calculus. If you want to take the derivative of an integral that's set up like this, as long as this is a constant, this gets plugged in, and of course, be careful about chain rule. And then if you want the second derivative, just write it. I really think it helps if you write these right below each other. I'm taking the derivative of the second side, or the left side, so it's like taking the derivative of the right side, keeping it balanced. If I want to know something about G prime of 4, that's the same thing as F prime of 4. And how am I supposed to know about the how am I supposed to figure that out?
You find the slope of.
Very good. The only way you can do it is slope. So that's why these are nice straight lines. So if you do rise over run, you're going to get slope there. That would be the slope. And that should give you your answer. You guys okay with these parts? How I'm getting these? Derivative of both sides, derivative of both sides. And then as you need G prime, you know what it's equal to. You need G double prime, you know what it's equal to. Okay, do we need to, can you guys get the answers to those parts now? Do we need to take time for that? Okay. Okay, part B. I think some of this is going to help later too. So I'm going to leave this on the screen. Find the instantaneous rate of change of G with respect to X at X equals 1. So instantaneous rate of change. What does that mean?
The slope at the
I'm concerned there. I think you're very close, but I'm concerned that you might be missing a part here. instead of instantaneous rate of change, instead of calling that slope, let's call it derivative. So this is what they're really asking for. They just put it in words instead of a symbol like part A. But if you have this written down right here, g prime of 1 is just the same thing as f of 1, which is just like taking a point off. Oh, sorry. This is actually the graph of f, not g. Sorry if that added some confusion. So when x is 1, y is 4. That's it. And if you already have this written down from part A, again, it's really easy to just say I'm plugging in 1 here, so it's going to be like plugging in 1 there. The answer is right here in front of you. They're just seeing if you know how to compute that. Okay, see absolute minimum. So if you're ever trying to find absolute max or min, you should be thinking extreme value theorem, which means you should be trying the endpoints and any critical numbers where it's like crossing the x-axis, which would be 3. So if you find those values, you'll see which one is the smallest. And to find those values, it would be like finding the area. So find the area from 1 to -2, find the area from 1 to 4, find the area from 1 to 3, and then the smallest value gives you that. Again, we can come back and actually do the arithmetic in here. Okay, D, the second derivative of g is not defined at x equals 1 and x equals 2. How many of these values are x coordinates of points of inflection? So if this is f, points of inflection of g. So points of inflection are when the second derivative is 0 or undefined. When the second derivative of this is 0, we don't have undefined here. That's when the first derivative of f, which we have a graph of, is 0 or undefined. And they're already telling us that happens at x equals 1 and x equals 2. The reason why f prime doesn't exist there is because those are cusp. Remember, you can't take the derivative at those sharp turns. But only one of those is going to be a point of inflection. So other than the second derivative being 0 or undefined, what else makes a point of inflection a point of inflection?
Changing the sign of the slope.
Change in what? I think you're close. Points of inflection are when concavity changes. So like when it goes from being concave up to concave down. But we don't have that type of graph in front of us to think of it that way. But right here, the slope goes from being positive to negative, but from here it goes from being negative to negative. And the slope of this is how you have information about that. That's why if you don't have these 3 things written down here, you're asking yourself questions that you're doing way too much mental stuff here. So this one changes, the derivative of f changes, and when the derivative of s changes, that's when the second derivative is changing. So he's going from concave up, because the second derivative would be positive, to concave down, but here it's going concave down to concave down. So only at that one time is there going to be a point of inflection. Where is it? Increasing, decreasing, concave up, concave down. So we already kind of talked about the concave up, concave down. But increasing, decreasing, so this stuff is above the x-axis, so that's going to be increasing. Below the x-axis, it's going to be decreasing. Sorry, we've only got just a couple minutes here, so I'm kind of running out of time. And then f, if you, and I also suspect some of you guys didn't quite get there yet, but f wants to have an equation of a tangent line at x equals 2. So this is one of the first things we ever did. Equation of a line they're telling you the X value. To get the Y value, you need to plug that in for the function, so you gotta do some work there. And then to get the slope, you're gonna have to get that from the graph as well. So we can go over those parts next time, but I wanted to at least give you some help on it. But those first couple parts, again, if you don't make this connection between how G prime, and F prime are equal to those three parts, then this one's pretty hard to do. So you might need to restart it from scratch if that's an issue. All right, and then one last reminder, because I'm certainly not trying to trick you. In fact, I am trying to help you guys out. U substitution, 2 questions. Both of them will come from just the first part of number 82. There's like 9 questions there, so 2 of those. And those will be worth 2 points apiece next time. So if you feel like you missed out today, for whatever reason, make sure that you are up to speed there, because that will also be a big part of our test. So, but for now, we got about 2 minutes, so we need to wrap it up. Did you guys enjoy your AMI days? It's a nice change of pace. Does seem about 50-50 on it. What do you not like about AMI days?
They're boring. Like you can't leave your house.
I couldn't leave my house. I like everything about AMI days.
Like if I can drive.
I'm not
Yeah, me
complaining
too.
about it.
I like couldn't leave my pool at my house.
Yeah, but you had work to do.
Yeah.
It's like the only class that I don't like. It's not your fault.
No.
It's just my schedule.
I wish I knew that, because then I'd give y'all more work.
Thanks you, Emily. They all have classes.
Part of, I mean, the problem is, like, I just don't know. We might get 2 more weeks of snow, and like, I can't back y'all in the corner. Like, we have to keep going. So we got to set aside time to review.
I hope we have more snow. I need another break.